Hello everyone, and welcome to this video where I'm going to be teaching a little bit about waves, how they move, and specifically Huygens or H's principle. So, there are many different types of waves. You've got surfer waves, you got your good old classic neighborly wave, you got your football stadium, and you got your princess wave. But today we're going to just be looking at water waves. We got sound waves, make little headphones here. That's a music note. And you got good old light waves. So there's a couple different ways that we can draw waves moving. I think classic typical is looking over top, and you've got different crests going out, kind of like ripples on a water surface. The other cool thing about waves is that if we have a source of wave here, like a light, this is a flashlight, over a long distance, eventually it starts kind of acting like a planar wave, moving more in a straight line over time.
So it's really easy to be able to see these waves in an actual real-life situation. We have here a Tupperware full of water, and we're going to make both circular waves by dropping this little ball into the water. There you go, it has some ripples. Or we could take the lid of a Tupperware that has a flat surface and flick it while it's in the water. And you can see the planar waves moving from right to left in this video, making planar waves.
And these planar waves are how we get what we call Huygens Principle. He's a Dutch guy, so a lot of people pronounce his name a little bit different. Huygens Principle basically states that for a planar wave to move, each wavefront, which is like the crest of the wave at different points, has many different points on it. We'll do that in a different color. So these points each produce circular waves going out from them of the same wavelength. So this dot here has a circular wave going all over. This guy here has his circular wave. This guy here has a circular wave. This guy has a circular wave. And basically, looking at where those waves are having constructive interference, we get another line of a wavefront. So this line eventually will become this line, this becomes that, and it moves forward to propagate the wave. So you, like me 3 days ago, might be thinking, all right, this is pretty cool, but what does it have to do with how waves actually work in life? I'm gonna show you. So when we have a planar wave coming and it meets a boundary, Huygens Principle shows us how good it actually is. So here we have our boundary, we've got our waves coming in, actually they're coming from over here. And when they reach this boundary, here the wave will either be reflected or absorbed. And here we're going to see that Huygens principle that is so important. Because this wave front at this point will make a new circular wave that comes out like this.
We're using the Tupperware now to make the planar waves behind the boundary. You can see right at that point where the boundary breaks, there are ripples that come through, illustrating Huygens principle. There's a little bit of interference from the side of the container, but the waves can still be seen coming from the boundary in a circular pattern.
The important thing about this and why these boundaries and things matter is because sound and other waves go around boundaries all the time. That's how we can hear people around the corner. So if we have a couple boundaries, one right here, and one over here, or up here, really anywhere else you want a boundary, you can see that the wave will come to this point, being a planar wave, and when it gets here, it'll make a circular wave coming out, just like we've shown before. When it gets to these points, any point on the wave will make a new wave. And this is how sound, light, and other things bounce around corners. Me and my buddies are going to illustrate this. Alright, so we're going to demonstrate how sound can go around corners based on the same effect. So we got one of our buddies. He's chilling down here.
Oh, hey.
There he is. Got one of them just around the corner.
That's it.
There's a door in the way. So we're going to be in here. Can you guys hear me?
I can hear you. Yep, right here.
Corners. So I'm going to illustrate how that worked, what we just did there. So you have me standing here with the camera. Let's pretend I'm laying down. This is bird's eye view. We got our door right here open. We got my one buddy standing here. He makes a noise. It makes a wave that goes out. Maybe over some distance it gets planar. Reaches this point. This wave goes out like this, find its way to my ear. These are very poorly drawn ears. I'm an elf apparently. And then my other friend was down at the bottom of the building. So here's my super amazing 3-dimensional artistic drawing of him being at the bottom of this building and me being in this window here. He makes the wave with his vocal cords, which goes out. You can see that it can't really get around the corner unless each point makes another new wave. There is nothing out in the street for the wave to bounce back. There's nothing on the ground that's going to make it come back at this angle. Well, it just won't work. It only works because Huygens Principle makes it so that each of these points makes another wave and the sound can come back in this window.